Okay, so this is our first example of the volume of pyramids. It's a very straightforward kind of example. Put the formula over here, and I put the example over here. So this is a very classic or typical kind of pyramid where the base, this is like the Egyptians, right? Where the base is a perfect square, and I don't know how perfect the Egyptians are, but I hear they're pretty darn close. Anyway, so the base is a square in this case, and that's what makes it a typical pyramid. Sometimes my pyramids, and the examples we'll see, they're not always going to be square. They'll have like a rectangular base sometimes, but that's okay. It's the same formula. The formula doesn't change, okay? So classic example, the base is a perfect square because it measures 5 by 5. The base, the square platform that this pyramid is made of. And then it has 4 triangles that go to a point. And that's basically it. Anyway, so this one has a height of 6. Sometimes they put the dimension or the height, drawing a little dotted line like I did from the center of the square base up to the point. But other times you'll see the height out here on the side too, right? They just say from bottom to the top measures 6 centimeters. Okay, so just be prepared to see those kinds of variations of the example. And let's go ahead and get started. So, like I said, we've already been using this formula, not exactly like this one, but very similar, right? So what do you think the L times W is referring to in the pyramid? It's that square quadrilateral, it's the area of something. If I'm multiplying 2 dimensions, you know, the L times the W, I'm talking about the area of something that has 4 sides. And how do I know that? Because remember that the area of a triangle is, again, the same thing, L times W, but it's divided by 2. And that tells me that it's a 2-dimensional figure with a point, and that's like a triangle. But if it doesn't have, we're not talking about any of that, we're just going length times height, or length times width, or length times height, it doesn't matter. You know, those 3 dimensions, doesn't matter how we order them. But if we're talking about those 2, we're talking about the area of a square or rectangle shape. And in this case, we're talking about the area of the base. So we're really going to, this first part of the formula is really referring to that bottom part of the pyramid, the area of that square. And that's just going to be 5 times 5, right? So the area of the bottom of this pyramid is 25 centimeters squared. But we're not asking for area. We're talking about volume, so we have to multiply by the 3rd dimension. And now that would be length times width times height, or length times height times width, however I've written it down in the other videos, I don't remember. But those 3 would be the volume of a box that would measure 5 by 5, and it would have a height of 6. But it wouldn't be in a point, it would just be a box, right? And now when I divide it by 3, now that box gets pinched into a point, making a pyramid. And that's kind of interesting why we divide by 3. Why are we dividing by 3? Because we're talking about a 3-dimensional figure. That's why. In the triangle, it was a 2-dimensional figure that got pinched into a triangle, into a point, into a 3-sided thing. And we divide this length times height, or base times height, or length times width, whatever, divided by 2. Why by 2? Because we're talking about a 2-dimensional figure in that case, the area, right? But okay, let's just get back to our problem here. So we have the formula. It's really straightforward. There's no pi in this one, right? We're not talking about circles or things that are round. So it's just length times width times height. Let's go ahead and do that. Length, this length times width, I'm always looking to find the area of that bottom part first. I'm gonna go 5 times 5. And the height is 6. Okay, divided by 3. So it's 2 multiplications and a division. That's it. And I would recommend to definitely do the multiplications first, okay? And that's because we want to get one number divided by 3, okay? So I'm going to go ahead and get the calculator out because it is going to be kind of a big number and I don't want to make mistakes and stuff, and I think it's just a little bit faster sometimes with the calculator. So 5 times 5, and I'll show you, I'll try to make it as clear as I can here. 5 times 5 times 6, okay, is equal to, let's just get that part first, it's 150. All right, so it's 150 now, divided by 3. And then we have to figure out what that's going to be equal to, okay? So, again, with the calculator, it's pretty easy. So I just go divided by, and if I just hit the divided by button, it says answer right here. It says answer, or ANS. And that is referring to the previous answer I got before, the 150. So that ANS is basically 150 divided by, I already have my divided by sign there, 3. And they get 50. Okay, but again, that was kind of an easy one. I mean, we kind of know what 150 divided by. It's like $1.50. It's 3.50 cents, right? So the volume is 50 centimeters. Oops. 50 centimeters cubed. And that's it. That's how we would solve that. Again, this is kind of a 1, 2, well, if you count you have to know the formula, right? Hopefully you have that step already in your head, right? Memorized. But 1, 2, 3 steps, and that's it, and you get the answer. Or if you have it already in your head, the formula, that is, it's just writing it down, doing one multiplication to get 150, and then, or 2 multiplications to get 150. But for the calculator, it's like 1 step, right? And then you just divide it and you get the answer, 50. Okay, so let's take a look at another one, a little bit different.